Hello, this is going to be my review on the final exam and the Leaving Certificate Calendar, the higher level applied mathematics paper. So I had a little squiz of this. Now, it did take a while to get on the SEC website, so I know people that scanned it online or whatever. I just wanted to wait for the official SEC copy to be released. Now, as I normally do, I'm going to give a general consensus on each individual question and then give a full review on the exam as a whole, as I always do. The one gripe I have is that you'll see that a lot of the questions are incredibly long and don't need to be have so many parts in them. But the first question wasn't too bad, and it appears to be that question one is always going to be involving some sort of graph theory concepts. So adjacency matrix, m squared, that's all okay. A bit of theory involving m squared, and then a fairly nice horizontal circular motion question. So all pretty standard. Okay, question 2, calculus in motion. It's all pretty much okay. This is a standard proof that everyone should know, basically. And then some sort of standard integration. This one was a bit tricky to manipulate, but isn't too bad. And then solving free in terms of S, greatest height and such. And then using dv/dt. So slightly differently, but something that students should be well accustomed to. Now, question 3, one of the first two of the Newton's laws and dynamical systems questions. This is where it was a bit odd with relating the coefficients of friction here. So a bit of an odd choice, but again, fairly standard after that. And then some minimum standing trees using prims. But then also drawing the network. Just a bit much, but okay. Now, question 4, vertical circular motion and collisions in the same question. This is not the only time this has appeared. It's appeared, I think it was 2016 or maybe 2015 that it appeared. So, fairly challenging. But again, if you kind of sat and stared at it for a while, you might have got it. But I think within the time, it was very, very challenging. And there's a lot of parts. There's 5 parts, 6 parts even to that one question. And I think, okay, I thought that was a minimum question, but no. Okay, the second Newton's Laws question, it was slightly simpler, but had a couple of weird, kind of novel concepts to it. Which is very odd. And then fairly standard kind of vectors question that might require you to think. So obviously set the dot product to 0, but also the magnitude. It's a bit odd, but as ever. Now, this is the first time we've seen dynamic programming in tabular form. And annoyingly, it's like the worst of the 4. It's the one where in pretty much all the resources, it's okay to actually go forward in time instead of backwards in time. So it's a bit of a really just terrible question. Like a really bad way to introduce dynamic programming. And I also don't think that's enough space. Stage and state, that's again standard theory. And then they have a part B in here about work done on elastic string. Yeah, it's a bit odd questions. Now, Dijkstra's question, again, fairly okay setup. It is actually a smaller network than normal, which I think is alright enough, but still quite complex. And yeah, it's another projectiles one, but all very. It's pretty much a standard question involving projectiles and collisions, but it seems to be an area that I know a lot of students struggle with. So another very difficult question there. Now, this is a bit of an odd difference equation question where you have to essentially form it by yourself. And the use of the word increase here in the context might have definitely thrown some students. And then that's just integration by parts. That's fairly standard. Now, probably one of the simplest linear motion questions at the start, and then just drawing a velocity time graph. That's okay. And then annoyingly bringing up oblique collisions in the same question, which I thought was a bit of an odd choice. And question 10, again, it's another second order difference equation, but this time it's inhomogeneous. Now, what I find really weird about this, and kind of quite strange, is near enough this exact question came up in the tuition center mock, which I think it must be a coincidence unless there's some underlying sort of elitism happening. I was talking about subscription services, it being particularly a second order inhomogeneous difference equation. So I'm just putting it out there. And then another projectiles question. So it's a very short one, but still another one. So my overall thoughts on it, yeah, too many questions. Like there's a lot of questions with parts that shouldn't include. And considering you're only running at about maybe 15 or 18 minutes per question, including time to double check answers, I think it's ridiculous. So I think they should either increase the time or lessen the number of questions that students have to answer. So even like in the old syllabus, even do answer 6 or something instead of 8, because that's roughly the same amount of time. And a lot of these questions are longer than the old questions. So for example, I would think the dynamic programming would take even longer than like the moment of inertia questions, which I found used to take quite a lot of time and a lot of thinking. So yeah, definitely have to have a word with the SEC about this one.